A European Space Agency spacecraft orbiting Mars has just pulled off something pretty remarkable. It pinpointed the path of 3I Atlas with accuracy 10 times better than what we could do from Earth alone. Now, before you panic, this comet isn't going to hit us, but what scientists learned from tracking it could be a game changer for protecting our planet in the future. So here's the deal. Between October 1st and October 7th, the ExoMars Trace Gas Orbiter, let's just call it TGO for short, was watching comet 3I Atlas as it zipped past Mars. The comet got as close as 18 million miles to the red planet on October 3rd. Now, 18 million miles might sound like a lot, but in space terms, that's pretty close. Before this, scientists were tracking 3I Atlas using telescopes here on Earth. They expected that adding observations from Mars would help improve their calculations a little bit. But here's where it gets interesting. The improvement wasn't just a little better, it was 10 times more accurate. Why such a huge jump? Two main reasons. First, the Mars spacecraft was about 10 times closer to the comet than Earth-based telescopes. And second, and this is key, it was observing from a completely different angle. Think of it like this. If you're trying to figure out exactly where a car is on a road, you'll get much better information if you have cameras watching from two different locations instead of just one. That's called triangulation, and it works the same way in space. This matters because 3I Atlas is absolutely hauling through our solar system. We're talking speeds up to 155,000 miles per hour. That's incredibly fast. And it's not sticking around either. This comet is just passing through and will eventually vanish back into interstellar space, never to return. With this improved trajectory data, astronomers can now point their telescopes with confidence and gather more detailed science before it's gone. Now, here's what makes this even cooler from a technical standpoint. The TGO spacecraft normally uses an instrument called CASS, that stands for Color and Stereo Surface Imaging System, to photograph the Martian surface in high detail. But for this mission, they turned that camera away from Mars and pointed it at the stars to capture the comet. This required some serious coordination. The planetary defense team at ES's Near-Earth Object Coordination Center had to account for where the spacecraft was in its orbit around Mars, how fast it was moving, and its exact position. This is really different from how comet observations are usually done, typically from fixed locations on Earth or from spacecraft orbiting our planet, like the James Webb Space Telescope. And here's a fun fact. This is the first time that position measurements of a celestial object have been collected by a spacecraft orbiting another planet and submitted to the Minor Planet Center. The Minor Planet Center is basically the central hub where all asteroid and comet observations from around the world, and now from other planets, get collected and analyzed. So why does all this matter? Well, planetary defense. ESA routinely monitors near-Earth asteroids and comets, calculating their orbits to provide early warnings of something dangerous is heading our way. This mission with 3I Atlas was essentially a rehearsal, proving that triangulating data from Earth with observations from another location in space can give us much more accurate results. And if a spacecraft happens to be closer to an object we're tracking, that's even better. The story doesn't end here either. Right now, another spacecraft called JUICE, the Jupiter Icy Moons Explorer, is also observing 3I Atlas. JUICE caught the comet right after its closest approach to the Sun, which means it's probably getting the best view of the comet during its most active phase, when solar radiation is causing it to expel material and put on a show. Unfortunately, JUICE is currently on the opposite side of the Sun from Earth, so we won't get that data until February 2026. But when we do, it'll add even more pieces to the puzzle. So there you have it, a European spacecraft orbiting Mars just helped us track an interstellar comet with unprecedented accuracy, and in doing so gave us valuable insights that could help protect Earth from future threats. What do you think about using spacecraft on other planets to help track dangerous objects? Let me know in the comments below. Thanks for watching, and I'll see you in the next one.